just like I added a few more things about the RS latch, I want to add a few more things about the that latch. So if you take the RS latch, you may want to do a few things. So if we start with the same NOR gate, and we have Q as the output, and we still have this and this, so it goes all the way down to here when we have where we have Q naught and another NOR gate, just like this, with which is connected here. So we will basically have an RS latch just like before, but this time I'm gonna add an AND gate here at the bottom and here at the bottom, and to here I'm gonna have R and S, and then from here E, which is the enable. Oh, sorry about that. I got cold. Okay, so here, and then it goes to here. And we also add a reset and a preset. Now, one more thing that we might want to do from here, we actually to add a NOT gate, because in this case, by doing this, we're gonna make sure that we're not gonna have 1 1, so we're not gonna end up in a state where S is 1 and R is 1, just like we had before. So in this way, we are going to avoid to get into the invalid state. And this one is actually called a D latch. So if I put a 1 here, for instance, what happens is that this one is going to be set to the set pin, the reset pin will be low, and the output is going to be 1. If we put a 0 here instead, then the set pin goes low, the set pin goes low, the reset pin goes high, and the output is just going to be 0. And I know that this actually seems, useless, because the output is gonna follow the input. But this is where the enable pin comes into play, because the enable pin, if you basically set it, I don't know, to 0, and we had 1 here, with the enable pin equal to 1. If we now set the enable pin to low, so to 0, it remembers this state. So what happens at this input here? If the enable pin is 0, so here is always going to be 0. It doesn't really matter. And as I said, we basically have a schematic for this whole thing, which is the latch symbol, with D, which is our input, Q naught, and E, which is our enable. So again, we have Q input and Q output and Q naught output, D as an input and E as an enable. If you get something like this going into the enable pin, then when the enable pin is high, we can put whatever we want, like, I don't know, something like this, and then we can go low and we stay low. So what we're going to have at the output Q is that at this point in time, it is following the output. So the output is going to be high. But then once the enable pin goes low, it's just going to keep the same value. So it's going to be like this and keep this value. And then the enable pin is just going to go high again. So it's going to, this one is going to go low. So the advantage of this is that you might have data that is changing at some point in time, or, you know, someone is entering something and they enter some data and you set the enable pin to high. But then you can say the enable pin to low, you can change the data to whatever, the system is just going to ignore it. Just going to ignore it. And we can actually extend this one over to what we actually call a D-type flip-flop. So what a D-type flip-flop is, let me just, whoops. I do have, yeah, I do have, should really have room for this. I have room here. Yeah, I do have room here. So as I said, this was, this is the latch, but we can actually extend this. And if we put those to the latch like so, let me just throw it. And we start with the D latch, like the one I just throw here, the D, Q, E, and Q naught. Again, D, which is the data, E for the enable, but with a NOT gate here, and we have the clock here, which goes all the way to the enable, but to another D latch, and we put the output of, we just ignore the Q naught, and we put the output of the Q into the second D latch. So into the data of the second D latch, we have E for the enable here. We have again Q and Q naught, which go to Q and Q naught. It's actually called a D flip-flop. I said that I was going to introduce flip-flops, so when we have a latch, as long as enable pin is high, the output is going to follow the input. But if we combine those two, if I put, for instance, like a 1 here and a 0 here, what we're going to have is that this one goes to 1, the enable pin is 1, so this one is going to go here. But this one, this enable here is 0, so the output is still going to be the old value. What you have to do is then set this pin to 1, so this one goes to 0, and this one goes to 1. At this point in time, then this data is forward to Q, so it's 1. So but this one is disabled, so even though the input changes here, it doesn't really matter because this one is 0, so just the former one just gonna go through, so it doesn't matter. So it's just this one that is forwarded to the output. So the flip-flops are kind of handy, to be fair, because they only change right at the edge when, you know, when we have this one, high, it's forwarded to the output, not high, it's not going to be forwarded to the output. With a T-type for flip-flop instead, if we have something like, I don't know, like this, when the clock is low, like here, the data just forwarded to this intermediate point, and when the clock is high, it's then forwarded here onward. So basically, whatever happens, you know, here, where there is the clock edge, is the data that is captured to the output. So at this clock edge is when we're switching from this data that is captured up to this point, forwarded to here, this clock time. When the clock is high here, these flip-flops just stops getting the data from here, from the data, and it's just gonna feed the second latch that just moves the data to the output. When the clock is low again, so it's here again, then this one is stopped because it gets a 0, and then the first flip-flop is just gonna get, you know, read the new data. So again, we can use another symbol and have yet another level of abstraction, and get this symbol here with D, Q, and Q naught, and this symbol here. If you see this symbol, we have of course set and reset. So with this symbol here, it means that it's edge sensitive. So at the clock edge, the flip-flop is capturing the data. So yeah, this is pretty much what a flip-flop does, and why it's convenient to use flip-flops instead of, you know, just spare the latches. So, you know, they're kind of useful. Those are very useful to store data, and there are different kind of way to store data, as I show you. So yeah, this is pretty much the introduction to flip-flops. We're going to continue with the next video. So stay tuned and bye for now.